So right now we are going to understand virtual memory in details. Right now we are going to learn and start our discussion on virtual memory. Why virtual memory is nothing but it's an illusion of a bigger memory. Okay, let's see here. You know hard drive, which is the bottom of our hierarchy. We have learned memory hierarchy. In that, we have seen that virtual memory occupy the bottom. Virtual memory is just like hard drives are the examples of virtual memory. Most modern computer use hard drive, which is made up of magnetic or solid state storage as the lowest level in the memory hierarchy. Now, in most of these modern computer systems, the hard drive is made up of magnetic or solid state storage. And the memory hierarchy is going from the fastest, that is the smallest registers, down to the slowest or the largest hard drive. This is just about how in the memory hierarchy it is basically arranged. The hard drive sits at very bottom and it's the last resort when data isn't found anywhere above it. Okay. If you haven't found any data in our main memory, in our cache, in our registers, then we will go and check our bottom of our memory hierarchy, that is hard drive, where the data would be there. Okay, so in this slide you have to just understand that the virtual memory is just an illusion of a bigger memory. If you haven't able to find the data anywhere, then we will be able to found it in the hard drive. And you have understood that hard drive is made up of magnetic or solid state storage. And then now let's talk about this hard drive. Hard drive is actually very large, but you have to understand, though the hard drive's size is very large, it is actually very fast and it is cheap. That is, you have to understand, hard drives is large but the speed is very slow. Sorry, this is about the DRAM. So there is a difference between this hard drive and DRAM that we have to understand. That is, hard drive, the size of hard drive is very large. Okay, and DRAM's size is limited because its hard drive is in TB and this is in GB only. That is, DRAM is in GB. Now the cost of hard drive is very cheap. We will be able to get different hard drives easily. You can purchase it very cheaply, but DRAM is very expensive. The speed, if you consider, since it is larger, it is slow compared to hard drive. The DRAM's speed is faster. So there is a huge capacity which is there in this hard drive. So you just here in the slide you have to just know the difference between this hard drive and DRAM. Okay, so if you see, this was our diagram where inside our processor chip there was CPU and our cache. Then we have the main memory. Then we are talking about this hard disk, our virtual memory. This much we have understood. Now let's see how a hard disk actually works. So here the hard disk contains one or more rigid disk or platers, each of which has a read or write head at the end of a long triangular arm. So there is some platers, that is rigid disk or platers in the hard disk. I'll show you the picture, but we know that hard disk looks like this with lot of disc or plates in it, and there is an arm for reading or writing. To decide, the read or write head is there. So this is actually how a hard disk. We know there are different. If you see here, this is one plate, the different disk platers and an arm. This arm is basically what? This is like I told you, it can be made up of magnetic storage. Hard disk is also there. Solid state is also there. So solid state drive can also be used in the hard disk. Now this is the read or write arm. So platers are spinning magnetic disk that stores the data. Read or write head, a tiny sensor which is on the tip of an arm that actually reads and writes data magnetically. So read or write head is used to read or write the data magnetically in the platers. Platers are something which is actually, this read or write head is basically there at the tip of an arm. Now arm is something which is going to swing the head to the correct position on the plater. To swing it on the correct position of the plater, we have the arm. Now, what do we platers do? Platers are spinning magnetic disc that stores data. So, platers are nothing but the spinning magnetic disc that is basically used to store data. Spinning magnetic disc. So, that you have to understand. What are platers? So, platers are the spinning magnetic disk that actually stores the our data. Then we have read or write head used to read and write magnetically. An arm is actually helped to swing this read or write head to across these to the correct position in the plater where you want it to be. Okay. Now let us understand the seek time. What is seek time? Seek time is actually the head would take several milliseconds to seek the correct location on the disk, which is fast from the human perspective but millions of times slower than the processor. So you have to understand that seek time is that okay. Seek time means our head has to move to a particular correct location. So it takes some milliseconds, that is some time, to seek to that correct location, right? So moving this arm to the right location is called as seeking, which takes around 5 to 10 milliseconds. That sounds tiny to a human. That time is very small. But modern CPU runs at a billion of cycles per second, meaning the CPU could execute millions of instructions in this time it takes to read one piece of data from the hard disk. We will see, okay, 5 to 10 milliseconds, we will feel like it's a very tiny, small time. But if you see, for us humans, we feel like that. But CPU takes at this particular time, the time in which the arm is seeking, that is finding the right location, by that time the CPU can execute millions of instructions, right, at that particular time. So this is the problem with virtual memory. This is a fundamental problem virtual memory must work around. That means it should reduce this seek time. That is the main idea behind the virtual memory. So for that, the first thing was happening was that SSDs replacing HDDs. First we had this hard disk drives which are increasingly being replaced by this solid state drives, because reading is faster and they are not as subject to mechanical failures. So why SSDs are used in the place of hard disk drives? Because solid state drives like hard disk, their reading is faster. You have to understand the reading is faster, right? Reading is faster where the reading is faster in solid state drives. So solid state drives have no moving parts. They store data in flash memory chips. So if you see SSDs, they have no moving parts. They can store the data using the flash memory chips. So they are much faster than HDDs, and they may not subject to any mechanical failures, and also more reliable. No mechanical arm is not there, or a spinning platter is not there. Therefore no mechanical failures would occur. Still much slower than DRAM. So the principle of virtual memory still applies. But though we feel like it is faster than HDD, but it is still slower than what our DRAM. That is why we are considering SSD also as a part of what? Of our virtual memory. So SSD is solid state drive, and it is much more reliable because it is having less mechanical failures, and during flash memory chips we will be able to store data because there is no moving part. So it is faster than HDDs. Okay, there is a microsecond millisecond difference between them. Fine, let's understood that. And now it is much slow, though these properties are there, it is much slower than DRAM. That is why we have still saying that this SSD is what? SSD is the part of our virtual memory. Fine. Now let's understand the core idea behind virtual memory. Now let's understand the concept of virtual memory. Now, a computer with only 60 GB of DRAM could effectively provide 128 GB of memory using hard drive. This larger 128 GB memory is called as virtual, right? That is, if the DRAM is 60 GB only, hard drive using hard drive they can store 128 GB of memory in it, and the smaller 16 GB main memory is called as physical memory. You have to understand there are virtual memory and physical memory. Now this main memory which is smaller is called as what? Physical memory, and the virtual memory which is having larger memory is known as our virtual memory itself. Fine, okay. Main memory is known as physical memory, then we have virtual memory. So virtual memory is what it is doing is it creates an illusion. Program think they have access to this 120 GB of memory, but the hardware only has 60 GB of actual RAM. So the remaining space is backed by the hard drive. So the program never needs to know the difference. A program would see what? Program would see like, okay, it has complete 128 GB. But here you have to say that actually only 60 GB of RAM out of this 120, only 60 GB only hardware is there, and the rest is not hard drive. Hardware is there, not hard drive. Okay, hardware is there, rest is hard drive, that is virtual memory's part. So it's creating, so program doesn't need to know, okay, there is a difference between RAM and virtual memory and all. Program doesn't want to know. Whatever it needs, it has to take. If the data is in the hard drive, then it has to go to the main memory and match it. So that is the thing that you have to understand. Program always sees like this 128 GB virtual memory, so we can take whatever we want from there. So this is called as a physical memory, this is called as a virtual memory. That is, this 60 GB of RAM is known as a physical memory, and this hard drive part is known as a virtual memory. So let's understand the difference between virtual address and physical address. Virtual address is the address a program uses referring to a location in a full memory space. Physical address is the actual location in the DRAM where data is currently there. So you have to understand that virtual memory is what? The address that the program is using, which is there in here, in this 120 GB virtual memory. And physical address is the actual location in the DRAM where this data is there. So you have to understand that we have to match it. From virtual address is the where the program actually uses, the address the program uses is virtual address, and physical address is the address in the correct location in our DRAM. So program always works with virtual address only. So the hardware has to do what? It has to translate this to what? Physical address, which is happening behind the scene. So you have to understand program is using what? Program would ask for what? Virtual address. So what we have to do, the inside the hardware we have to convert it to what? It's happening inside the hardware itself. We have to convert it into physical address, right? That's what we have to do here. So this is happening inside our this would happen where inside our hardware itself. So it's happening behind the scenes. That's what you have to understand. So here if you see physical memory as a cache for virtual memory. So this physical memory, we told you cache is what we know, what is cache and how it is related with main memory. So now we have to understand one important thing is that the physical memory is like a cache to virtual memory. See, that is, physical memory would hold just the subset of the virtual memory, subset of the most recently used in the virtual memory, like how it was like cache. But this time virtual physical memory is like a cache to what? Physical memory is cache to the virtual memory. So L1 L2 cache, virtual memory equivalent is physical memory. For main memory, physical memory, main memory if you consider this would act as a cache, and the virtual memory equivalent is what? Hard drive. Now cache block, cache miss, there are some other things, like if you see in cache there were some blocks which is of the memories block. They are the pages here. Okay, here we will discuss that as pages. And we have said cache miss and all, right? So here we will say page fault. So blocks are called as pages. Blocks are called as pages, and the missing of this cache is known as what? Page fault. Like that, it's like like how it was happening. Our terms which we use in the cache, how we are using it in the virtual memory. That is what we are understanding here, and we will talk about page and page faults detailedly later. Okay. So here, if you see pages, the unit of virtual memory, right? So pages are like blocks. Just like cache works in blocks, virtual memory works in pages. So virtual memory is sliced into fixed size virtual pages are there, and physical memory is sliced into equal sized physical pages. Virtual memory also virtual pages, physical memory has physical pages. Fine. So a virtual page can live either in DRAM or in hard drive at a given time. We know. So if you consider in virtual memory, there is page 0, page 1, page 2, page 3. These can be there. Some can be there in the RAM or some can be there in the disk. Okay. So that means here page 0, page 2 and all is there. Page 0, if we consider here, physical page 3, physical page 7, physical page 1, let us say. So here this virtual page 2 is there in physical page 1, and virtual page 0 is there here. And the rest pages in the virtual memory is there in the disk. Some of the virtual memory pages, that is virtual pages, will be there in the physical memory, and some would be there in the disk. Okay, like blocks here pages are. So now let's talk about address translation. That is some important thing that you have to understand. The process of determining the physical address from the virtual address is called as address translation. So address translation means virtual address is converted into physical address. We have to convert virtual address into physical address. This is called as address translation. Now how can you convert this? When a program is accessing a virtual address, the hardware must figure out where that data is actually present in our physical memory. So it has to convert. So there is a page table. Now this page table will help us to decide that virtual address would have in which page in the physical address it is belonging to. That you can understand using page table. That is this virtual address. Let's say the address is, let's say, in virtual page 0. So that page 0 is present, let's say, in page 3 in our physical address. That will be there. There's a page table which will tell us, okay, this virtual page is present in which physical page? In page 3. So there is address translation, and then from there we can access it from our DRAM. Now page fault means what? Page fault is like page miss. CPU is trying to access a virtual address. That page is not present in DRAM. It's on hard drive, let's say. So what happened? A page fault would happen. So what happened? OS would takes over and is find the page on the hard drive, and OS would load that page into a free physical memory slot there. Now in the physical, like how it did, if the data is not there in the main memory, then data is not there in the cache, then we have to go and check it in from the main memory and load it into the cache. Like that, if the page is not present in the DRAM, that is on the then it will be there in the hard drive. So page fault would happen. So OS would take over, and what it will do, it will find the page on the hard drive and it has to put it in a free physical memory slot. So now CPU retrieves the access and now it is succeeded. So this is what page fault means. So let's understand. Block here in virtual memory is page. Block size here in cache it was here in virtual memory is page size. Block offset in cache was known as page offset. Miss is known as page fault, and tag is a virtual page number. Here through page number we will be able to access it. So some of the virtual addresses, you have to understand that virtual address is the physical address in the physical memory. Some of this would be there in the hard disk and some of them will be there in the main memory. So in the total virtual address, if you consider, some of them is there in the hard disk and some of them are there in the physical memory. Address translation is converting this virtual address into physical address. Understood?